All right, I'll start. Good evening, teachers. Good evening, everyone. So, welcome to EI webinar series. I myself, Saloni Shah from the academic consultant team, and Ms. Diksha Khare from the content development team, welcome you to the EI webinar series. Our today's topic is understanding math misconceptions to build stronger foundations for grades 7 to 10. So, our focus on today would be the role of a good diagnostic tool to unearth misconceptions. We will then try to understand certain misconceptions and we will look into examples of misconceptions based on EI ASIC 2025 papers. Finally, we will have certain best practices that will leverage misconceptions. All right, when I'm talking too much about misconceptions, I have some slide in front of me which talks about 4 pictures. Teachers, if I may ask you to pinpoint certain similarities and dissimilarities amongst these 4 pictures, you can put that into your question and answer box. Please use the Q&A box to fill up the similarities or dissimilarities that you find in the pictures mentioned here. All right, so let me take this. We have certain answers here. And yes, we can see that in the first 2 images, we see in the first image where Virat Kohli is being given feedback by his coach. And even in the second image, we see in the MasterChef competition, we have the judge given some kind of judgment or some kind of suggestion to the contestant. We also, in the third and the fourth image, also talks about Indian Idol, where the judge is given certain kind of suggestions and or the feedback, and even the assessments, we receive certain kind of feedback. So in each and every picture, if we see what is similar is there is feedback given at some or the other point of time. However, when I talk about dissimilarities, in the first 2 pictures, we see that the feedback is given during the event, that is when the during the match is going on or during the competition. However, if I see Indian Idol and the assessment taking place, in Indian Idol competition, the feedback is given at the end of the song. Like once the song is done, the feedback has been given by the judge. And similarly, even during the examination, once the child is done with the assessment, the feedback is given by the teachers later on. So at end, we all feel that feedback is very important. And I hope all of you will agree to me on this, that in each and every field, we require feedback to improve ourselves. When I'm talking about feedback in the education system, we have something called the teacher and student loop. That is, a continuous thing is needed in the teacher and student thing. When I'm talking about, when I say that a teacher gives a feedback to the student, how does a teacher give feedback to a student? Of course, through their answer sheet, like when they give an answer, the teacher will be of the opinion how the answer is, and on the basis of the answer, they will give you a suggestion whether what concept is good, what is weak, where the student have to work out, and where not. Similarly, the student gives feedback in a way by answering right kind of questions to the teachers, by doing their classwork, by doing their assignments. This is how the teacher will come to know that yes, where my students are lacking or where they are doing good. So this is a continuous feedback loop that we need in education system. However, there are certain kinds of problem that students face. The main problem that our Indian education system is facing is something about rote learning. That is, when I'm talking about rote learning, it is where children are actually trying to answer the questions without really understanding the concepts. If I talk about examinations like PISA, and if I say why the ranking of India is so low, what is the problem? What is the matter out there? The main problem, the main matter is about the rote learning, where children actually do not understand the concept properly and just write the answer for the sake of writing. So, what's the solution to it? Now, before moving to the solution, there is a very famous saying by John Bitts who says that what and how students learn depends to a major extent on how they think they will be assessed. I hope all of you will agree to me on this. If I feel or if we say that the students will be assessed on the basis of their memorization power or on their remembrance skills, then it's tend that the students will be preparing themselves on the basis of memorizing power. They will try to memorize each and every concept or each and every chapter instead of actually understanding what the concept is all about or what the problem is actually stating. Similarly, if we say that or if we are trying to make our students understand that, okay, listen, you will be able to understand or you will be able to appear this paper only if you will critically think. So if I'm trying to assess my students on the basis of critical thinking, he or she will try to prepare him or herself on the way that, yes, I have to really had had my brain to make me answer this particular question. So yes, they will then try to develop this method of critical thinking. So it very much depends on how the students think that they will be assessed. When talking to the solution of the problem of why we are scoring so less or why is India behind, is one thing that we can majorly take is upon the assessments. We can mainly think about improving the quality of assessment by asking the right kind of questions. However, just by asking the right kind of questions is not the end to the problem. Using the insights from the assessments will also help us to modify the teaching on the learning process. So wherever is the insights meaning, that means the report card. If I see my report card all together and if I come up with some of the other solutions or, trying to figure out where the children are lacking, and if I try to revert on the same, I will come to know that where the children are lacking and we can try to implement that into a classroom. That can eventually change our teaching and learning methodology. EI Asset does the same thing. It helps us to give you feedback. So what EI Asset does is we give you the question papers, and on the basis of the question papers, on the responses of the students, we collect their feedback and we give it to you saying that, yeah, this is the responses, this is what the skills that they are strong in, and this is where they are lacking. So we call EI Asset as a diagnostic tool. That means it gives you an in-depth view of each and every student's performance. We also call EI Asset as a benchmarking tool. When I'm talking about benchmarking, it means that we try to compare the results of your school, your students, with the students around your locality, even at your city level, at the state level, and finally at the national level. So we try to compare students at each and every level to see where the students are actually standing. After that, we try to give you certain kinds of misconceptions. What are misconceptions and how it is, we'll look into a further part, which in turn will develop the teacher effectiveness. Now, when I'm talking about misconceptions, let me pinpoint this. What are misconceptions? So many a times, what happens is in a classroom where we have students from different mindset, whatever is always taught in the classroom does not mean that the students are taking the same learning. So what is taught is not always what is taken by the students. We call this as a gap between them. So we call this as a learning gap. And now this learning gap is nothing but the misconception. So what is taught and what has been taken by the student, a thin line, which is called a learning gap, is being termed as a misconception. So let me give you a clear example on what misconception is. Now let us have a look at this as a question. Which of these is a triangle? So when I'm saying this, which of these is a triangle, and we have options as A, B, C, and D, let me show you the data. As for the national performance, it states that most of the students have answered the correct option, that is option D, which is only shapes 2, 3, and 5. However, we see some students also attempting option A as the answer, which is only shape 3. When I'm talking triangle as a figure, we all know that triangle is a three-sided figure. And students only tend to take that, yeah, it's a three-sided figure. And only that is, we see such type of triangles into our textbooks. A straight triangle with three-sided enclosed figure. We try to see such kind of triangles into our textbook. And that's why students have this mindset that, yeah, only this is a triangle. However, even if I tilt a triangle in another way, if it is upside down, students fail to recognize that, no, this is also termed as a triangle. Even in shape 4, if you see, the triangle is incomplete. What do students try to feel is this is not an incomplete figure, it's just a printing error. So if it's a printing error, they also try to tend this as a triangle. They also try to make it out that okay, shape 4 is also a triangle. And we can see that into a national performance. So whenever we are trying to explain a topic called triangle, we can emphasize on the word saying that triangle is a closed three-sided figure. So children tend to forget that a closed figure is a triangle and try to maintain that everything that is three-sided, it's a triangle. Also, that something that is upside down is also a triangle. This can be also explained to classroom using different objects and including certain practical examples as well. So this is what we call a misconception is. Now, what do you think? Why is it important to know and address misconceptions? Of course, we all feel that misconceptions are there. And it's also important. I hope all of you will agree to me that yes, it's very much important to address those misconceptions. So let us see how can we do that. And why, first of all, then why are this, why is it very much important for us to address it? So the main thing is because misconceptions impede the learning of other concepts. Let me give you a simple example. If my child is not able to find out the length of this pencil, do you think that in future my child will be able to find out the measure of this angle shown here? These are all linked, isn't it? So if a child is not able to measure a pencil correctly, the person will not be able to even put his protractor right down on a straight line and try to measure an angle shown. Similarly, a learner may also be unaware that the knowledge that he or she has is a flawed one. At times, many a times, in fact, it happens that the flawed reasoning may lead to the correct answer. And hence, the child may think that, okay, the answer is correct. It means what I'm assuming or what formula I have used or what logic I've implied is the correct logic just because I've got the answer true. However, many a times it is possible that whatever he has done or he has thought is flawed. So we may or must try to avoid this kind of things. So any ordinary form of instruction such as lectures, labs, or just simply reading texts will not be very much successful amongst the students who are just seated into the classroom. For them, it's very much important that we have something called the practical examples being given into the classroom for each and every concept that we are trying to target. So today, ACIT, as we all know, touches different skills and has a lot of questions on all the skills of mathematics. However, keeping the time constraint in mind, today we'll be focusing on three main topics, which is mensuration, exponents, and algebra. So let's have a look on certain misconceptions that we found out on mensuration, exponents, and algebra one by one. Keeping to the first topic, mensuration, let's have a look at this class 7 perimeter question. Which of these shapes has the greatest perimeter? So, since I have my colleague, Miss Diksha Khare from the content team, Diksha, I would, if you can please help us highlight the right answer out here and certain misconception that the students are facing here with the data, please, if you can just do
Yes,
that.
sure, Saloni. Thank you. Thank you for giving a great introduction to the webinar and also speaking about misconceptions, why is it necessary to address them, and in the next few minutes, we'll see what kind of misconceptions exist among the children and how we can remediate them. To begin with, we have this class 7 question: which of these shapes has the greatest perimeter? There are four different shapes, and as you can see, um, if you find out the perimeter of each of these shapes, you will see that option B, because it is more spread out, will have the greatest perimeter. Uh, right, we all know that option B is the correct answer. But interestingly, data suggests that 42.6% students have gone for option C. Almost the same number of students have gone for option C. Now we call this option C as common wrong answer. What do we mean by common wrong answer? It is that wrong answer which is chosen by a lot of students or a big chunk of students. Why is this common wrong answer important to us? Because it gives us valuable insights on the student thinking, on the kind of misconceptions that students have. For example, let us try to see here what insights can we draw from these many students choosing option C. Now, the first option, the first shape in the first option is made of 8 squares. Option B is made of 10 squares. Option C is made of 11 squares. Option D is again made of 8 squares. That means option C, which occupies the largest area, is chosen by most, I mean, at least a big chunk of students, thinking that it has greatest perimeter. Now, what is that misconception that led students to go for option C? Is that students think that larger the area, greater is the perimeter. In this case, the shape in option C has the largest area, hence students think that it will have the greatest perimeter. Let us see one more question, which is from class 8. Saloni, you
Yes,
want
Diksha.
us to? Yes.
Yeah, so I'll just have a go through on this question. Avni is made in shapes using four identical square tiles. Tiles do not overlap. Some of the shapes she can make using four such tiles are as shown below. Which of these must be equal for all the shapes that can be formed using four such tiles? Only area, only perimeter, both area and perimeter. Or D, we cannot say without knowing the shapes made. Yes, Diksha, if you can help us with the misconception and the data, please.
Right. So, as we can see, each of the four shapes is made up of four identical square tiles. So, what do we know? We know that their areas must be equal, right? This is the basic understanding which is expected from the kids. That means the correct answer to this is only area. Which of these must be equal for all the shapes? Area, only area must be equal, because we cannot say about perimeter unless we calculate the perimeter of each of these shapes. Now, now that we know what is the meaning of common wrong answer, I want you all to tell me which among option B, C and D is going to be the common wrong answer. There will be a poll on the screen. Can we have the poll, please? So, I want you all to select that option which you think could be the common wrong answer. Obviously, option A is out of question because A is the correct answer. Among B, C and D, which one do you think is going to be the common wrong answer? We'll have the poll for say 15 seconds more, and then we'll close the poll. I hope the poll question is clear. Which of these is the most common wrong answer? Is it option B or C or D? Yeah, I think we can close the poll. Can we have the results of the poll, please? Okay, great. 79% of the teachers think that option C is going to be the common wrong answer. Let us see what actually the data says. The data is in line with what the teachers are saying, which is good, which is a great thing, because um, teachers are able to identify the misconceptions that students have in this topic. So, as you can see, almost 39% students have gone for the correct answer. But then there are a good number of students who think both area and perimeter of these four shapes are going to be same. And what caused this? This is caused because of the misconception that they think that equal areas will always have same perimeter. The students think that if the area of two shapes are equal, then their perimeter is also equal. This is the misconception that has led students selecting option C. Yeah, let's move to
That's
next question.
indeed a misconception, Diksha. All right, let's move to a class 9 perimeter question. Ramya, Ankur, and Parul cut three identical rectangular sheets of papers into two parts. Shown below are their sheets after cutting. Who has cut the sheet in a way such that the two parts have the same perimeter? A. Only Parul. B. Only Ramya and Ankur. C. All Ramya, Ankur, and Parul. D. None Ramya, Ankur, and Parul. Yes, Diksha, if you can help us with the answer, the option, and the misconception along with the data, please.
Yes. Let us first try to understand the question. Ramya, Ankur and Parul have three identical sheets of paper and they are making these cuts. Let's try to analyze Ramya's sheet of paper. It has two parts and as you can see, this width is common in both the pieces. This piece also has the width which is identical to this width and also the length is common in both the parts. And regarding the path along which the cut is made, it is obviously equal in both the parts, right? So the perimeter of both the parts is equal in case of Ramya. A similar logic can be applied in case of Ankur, as this part is identical to this part, this side is identical to this side, and the path along which the cut has been made is equal in both the parts. So perimeter of this part is equal to perimeter of this part, unlike Parul's case where the perimeters are different. Now, so the correct answer is option B. Based on our analysis, option B is the correct answer. But let us see what the data tells. So the data tells that 24% of students have gone for option B. That is, none of them have their rectangular sheets of papers with two parts having the same perimeter. Now, what could have led students go for option D is that if you see in each pair of parts, the areas are different. The area of this triangle is less than the area of this triangle because it has a protruded, it's not a triangle. Area of this part is different from the area of this part because of the protruded triangular region here. Again, area of this is clearly visually lesser than the area of this, and area of this is clearly lesser than the area of this. So students have the misconception that different areas lead to different perimeters. And this is the reason students have gone for option D, which is none of the pairs have two parts with same perimeter. This is interesting, isn't it, Saloni?
Right, Diksha. Yeah, and it's so, in fact, when you are explaining, I also feel that, okay,
Mhm.
looking at this way, when I'm seeing the area part, it's very much confusing with the perimeter part. So students tend to forget what area is and what perimeter is when such kind of questions are being asked. So
Correct.
a great question, in fact, I must say. When we move to the next class 10 surface area and volume question, let's have a look at this question. Each object below is made up of 6 unit cubes. Which one has a larger surface area? A, B, C, or D?
Yes.
Yes, Diksha, if you can help us with the misconception and with the data, please.
Right. So as we can see here, each object is made up of 6 unit cubes, identical unit cubes, and we are trying to ask which has the largest surface area, A, B, or C, or D, if students think all of them have the same surface area. At this point, I will be launching a poll, and I want you all to tell me what is the common wrong answer. Based on the misconceptions that we saw so far in 7, 8, and 9 with regard to area and perimeter, try to extrapolate that misconception and think what lot of students might have gone for. And option C is the correct answer here. So that is out of question. Among A, B, and D, which one do you think is the common wrong answer? We do not want the correct answer, which is option C. I'm helping you so that you do not have to spend time on determining which option has the greatest surface area. C has the maximum faces exposed, hence the surface area of option C is maximum. But what is the common wrong answer? We'll take 10 seconds and for the poll. All right. Can we have the results of the poll, please? Okay, great. 38% 38% teachers think that option D is common wrong answer, and 31% think it could be option A, and 23% students think that it could be option B. Let us look at the actual data. What actually students chose in the last summer round. So, as a lot of you correctly pointed out, option D is the common wrong answer. That is 28% students have gone for option D. There are some students going for option B and A as well. But what misconception? What is the underlying misconception here? See, the interesting part about this question is we saw what kind of misconception students have between area and perimeter, and those misconceptions have a cascading effect when it comes to volume and surface area. The same misconceptions, if not addressed properly, if not remediated in time, will have ill effect on the advanced concepts when they learn different concepts in the higher grades. And in particular, in this case, what is the misconception is they think that equal volume implies same surface area. Because each of the three shapes are made out of 6 unit cubes, the volume is obviously the same. So the students think that surface area is also going to be the same. That is the reason a lot of students have gone for option D.
Correct, Diksha. So that's what we also call spiral learning, that if we have something not cleared in my earlier ages, I'll keep on carry that forward into my rest of the classes. A very good example on that. So Diksha, we saw a lot of misconceptions on this topic, surface area, volume, and perimeter. So if you could suggest certain kind of remedies that we can take forward and
Right.
can try to implement that into our classrooms.
Sure. Um, I would like to share a few remedies, remediation suggestions, but this is not an exhaustive list. Just an attempt to share a few tips and tricks that we can use so that it helps us in two folds. One, it will avoid any misconceptions getting created during the learning process, and it will also help remediate the misconceptions once captured through our assessments. So one will happen before misconceptions are emerged, and one will happen after the misconceptions have already emerged and we are trying to fix them. So this is a twofold um, mm, objective of some remediations that I'm going to share. First and foremost, before introducing the terms of perimeter and area, talk in terms of boundary of the figure, space enclosed inside the boundary. It is important to give them the experience of concept before introducing them to the technical terms of those concepts. So at least in the beginning, while you introduce area and perimeter, stick to always saying boundary of the figure and area enclosed, space enclosed by the within the boundary. That way, students can differentiate between the two concepts of area and perimeter. Then introduce the idea of perimeter through non-standard shapes. I have always seen teachers using standard shapes. They never use, not all, at least some teachers, they do not use irregular shapes or non-traditional shapes or variety of shapes while teaching the concept of perimeter. They will stick to the standard looking say rectangle or triangle or a polygon while teaching the concept of perimeter. But instead, we should expose students to different kinds of shapes, be it regular, irregular, let it have straight edges, let it have curved edges. Some are shown here. So try to expose students to many different shapes while you teach area and perimeter. Get students to arrive at the formula of perimeter on their own. With instead of saying area of the perimeter of a rectangle is 2 times length plus breadth, or perimeter of a square is 4 times the side length, make them do on their own or make them find on their own what is the formula for the perimeter of a square, what is the perimeter formula for a perimeter of a rectangle. That they can do only when they understand the concept of perimeter, right? So this will reinforce the understanding of concept in return. Also, introduce compound shapes that are formed by combining two or more shapes. Another popular, or I would say deep rooted misconceptions that we see in our asset questions, through our asset questions, is that students think that the perimeter of a compound shape is the sum of the perimeter of its components. That means they think that perimeter of shape 1 plus perimeter of shape 2 plus perimeter of shape 3 gives perimeter of shape 4, which is not true. I know that, you know that, we all know that. But how we cannot expect students to realize this on their own, right? So in order, mm, and hence as teachers, we need to show them these kind of examples, work out the perimeter of the compound shape, work out the perimeters of all these components, and show them how they are not equal. Is whether the sum greater than the perimeter of the this shape, or is this greater, show them all kind of relations. Lastly, give students sufficient problems to investigate the relation between area, perimeter, and what happens to one when the other is changed. For example, look at this first set P and Q here. We have formed Q, shape Q, by moving just one square downwards here from P. Now, what happens to the area? Area remains the same even after the shift because the number of squares is the same. What happens to the perimeter? If calculated, it shows that perimeter of both the shapes is the same. So this is the first case where area remains the same, perimeter remains the same. Now look at this case. Here, area remains the same between P and Q, but the perimeter has decreased. Perimeter of Q is less than the perimeter of. Now look at this case. Again, okay, in this case, area increases because we have increased the number of squares, but perimeter decreases. And in the last case, area increases, perimeter remains the same. Now, what does these cases tell you? It tells you that the change in area is independent of the change in perimeter. One cannot interrelate the change in area with change in perimeter. Only when you expose students to more and more these kind of cases, students will realize the concept of area and perimeter and how they are not interrelated or how they are related to each other.
Correct, Diksha. This is quite helpful, in fact. So, Diksha, let's move to the next set of questions from our next topic exponents. Let's have a look at the very first question from class 9. The concept that has been tested out here are the laws of exponents. And the question states which of these is the same as 3 plus 3 plus 3, the whole raised to 25. A, B, C, or D. So, Diksha, if you can help me out with the misconception along with the data, please.
Yes. So here we are testing loss of exponents. Which of these is the same as 3 plus 3 plus 3 whole power 25? And it is obvious for all, for us, that 3 plus 3 plus 3 is 9, which can be written as 3 square. So the correct answer is option C, which is 3 to the power 2 into 25. Once we convert 3 plus 3 plus 3 to 3 square, then the multiplication law can be applied to write it as 3 to the power 2 whole to the power 25, which is 3 to the power 2 times 25. Now, C is the correct answer, but what do you think the common wrong answer could be? What a lot of students have gone for is option A. And look at the number, almost 50% of the entire nation, almost 50% of the class 9 students have gone for option A. And when I say 50%, the number is, it's not a small number. The number of students who take asset exam is easily more than 13 to 14,000 every round. So half of 13 to 14,000 students have gone for option A. What they have done here, 3 to the power 25 plus 3 to the power 25 plus 3 to the power 25. What does it show? It shows that there is a gap in the understanding of concept of exponents, and there is a gap in the application of laws of exponents, or I would say students do not know how to do operations on exponents, be it addition, multiplication, raising the power, and the combination of these, students are unable to do that.
Correct, Diksha. Let's move to the next question. Class 10 exponents, 2 raised to the power 1 by 3 plus 2 raised to the power 1 by 3 equals to 2 raised to k. So let's see the misconception here along with the data.
Yes. As you can see, data is on the screen and the question is 2 power 1 by 3 plus 2 power 1 by 3 is equal to 2 power k. Then what is the value of k? Now, how do we solve this? So 2 power 1 by 3 plus 2 power 1 by 3 can be written as 2 times 2 to 2 power 1 by 3, right? Because there are two 2 power 1 by 3's, we can write it as 2 times 2 power 1 by 3. Now, what is 2 power 1 into 2 power 1 by 3? Because it's 2 times 2 power 1 by 3. So, 2 power 1 into 2 power 1 by 3. So, 2 power 1 plus 1 by 3, which is 2 power 4 by 3 is equal to 2 power k. Therefore, k is equal to 4 by 3. But only 19% could get this correct, and again half of the class 10 students, similar to what we saw in class 9, half of the class 9 students could not apply the law of exponents. Here half of the class 10 students are not able to apply the laws of rational exponents. Do you see how this is having a cascading effect? Like Saloni mentioned in the beginning, if a child cannot measure using a scale properly, then the same child won't be able to measure an angle using a protractor in the higher grades. And this is the pattern we have been observing in each and every topic, be it area perimeter, be it exponents, be it algebra, be it geometry. If the concepts are not made stronger in the beginning, they will have a negative effect later on. Now, there is an interesting modification of this question from last year. Okay, I just want you all to observe here. The left hand side is known, left hand side of the equation is known, and right hand side of the equation has a unknown, which is k. Now, interestingly, This was asked in last summer 2024, in which left side of the left side of the equation had unknown and right RHS of the equation was known. So we thought there may be difference in the performance because one has LHS unknown and the other has RHS unknown. But interestingly, or I would say strangely, this also almost had same performance as the other one. The other one was 19 point something and this one is 18.7, which is almost as close to 19. And at the same time, the other one had 50% common wrong answer performance, and this one also has almost 50% common wrong answer. That means students are not able to, so see, this is how do we solve this? 2 times 1 by r is equal to 2 to the power, sorry, 2 times 2 power 1 by r is equal to 2 power 5 by 4, which is 2 to the power 1 plus 1 by r gives 5 by 4. That gives r is equal to 4. But what students have done, 2 power 1 by 4 plus 2 power 1 by 4 is equal to 2 power 1 by r plus 2 power 1 by r is equal to 2 power 1 by r plus 1 by r, which is 2 by r. 2 power 2 by r is equal to 2 power 5 by r, 5 by 4. Therefore, r is equal to 8 by 5 they have got. This is the misconception that they are unable to apply laws of rational exponent. We saw both the variations. They were unable to apply laws of whole number exponents also. They are unable to apply laws of rational exponents. And if you check the ones with negative exponents, students are struggling there as well. And yeah.
Yes, a lot of struggle, in fact. And yes, okay, so let's see, have a look at our next. But before moving to the next topic, if you can suggest certain remedies out here,
Yes.
which we can take ahead.
Yes. So with loss of exponents, the best remediation, I think even the educators, researchers all agree with this, that the best remediation as far as loss of exponents is concerned is to make themselves derive the loss instead of us stating them. For example, if you want to teach them multiplication of exponent, law of multiplication of exponents, just tell them to solve this. 7 power 5 into 7 power 4 is equal to 7 power m. Then what is the value of m? The students are expected to expand this 7 power 5 into 7 power 4. Once expanded, they will calculate the number of 7s and write the LHS as 7 power 11. Sorry, 7 power 9, and then they will find the value of m as 9. But that is not enough. You should give more and more examples of this kind and ask them to see if there is any pattern in the answer. If they are able to find the pattern in the answer, then the half work is done. They can then generalize it and write or come up with the law on their own, which is t power m into t power n is equal to t power m plus n. This is just one example because we all know that there are several laws of exponents, and every law of exponents can be made, or students can be made derive every laws of exponents by this method, which is from concrete to abstract. That is, we first give examples, show them what is happening, help them to identify the pattern, and then write the generalized version of the law. Right? So these are
Correct,
some
Diksha.
suggestions for teaching laws of exponents. Yeah.
Correct, Disha. So, in fact, whatever we come up on our own is always that we remember till the end. So that's so
Yeah.
that students can try to come up on their own. All right. Let's have a look at few algebra questions. Okay, so moving to the first question of a class 9 quadratic equations. What are the factors of k square minus 7k plus 12? Versus shown below is a polynomial with integral coefficients x squared plus dash x minus 11. For what values in the empty box can this polynomial be factorized? Yes,
Right.
Diksha, if you can just help us with the data, please. Yeah.
Yeah. So as Saloni read out, there are two questions on the screen, question number 1 and question number 2. Question 1 says, what are the factors of k square minus 7k plus 12? Question 2 has a quadratic polynomial with a coefficient missing and asks what can come to the box so that the polynomial can be factorized. Now there will be a poll on the screen. I want you all to tell me which question performed better. Is it question 1 or is it question 2? Can we have the poll, please? Yes. Which question performed better? Question 1 or question 2? Let's take 10 seconds for the poll. Okay, everybody has answered. We have 100% answer. Right, 78% teachers have gone for question 1. They think that the question 1 performed better, and 22% teachers think that question 2 performed better. Let us look at the real data, actual data, which question has what performance. As most of you rightly pointed out, first question has performed better. It has got 59% performance, and second question has a lesser performance, around 25%. Now, what is the problem here? First question is fairly simple. They do this kind of they solve this kind of questions very frequently in their textbook. There will be quadratic equations given, and they will be asked to find the factors of the quadratic equation. They would have either rote learned it or mechanically practiced it, doing grouping technique and finding the factors of the polynomial. But do you think this question, solution to this question, is any different from solving this question? No, right? Even the solution to this question follows the same principle as this. What should students do? They just have to multiply the coefficient with 11. They will see that the product is minus 11. 11 is a prime, so it has to be either 11 with a negative sign. So it has to be either minus 11 plus 1 or plus 11 minus 1. In either cases, it will be either minus 10 plus 10 or minus 10. So the procedure is as good as this. If students can solve this, 59% students can solve this. Why can't they solve this? Because they have not understood the concept of factor and the process of factorization and what is the question trying to ask. This is where they need support. They can do these kind of commonly formed questions, but they cannot solve unfamiliar questions. But not that they don't know how to solve it. They very well know how to solve this, but they do not understand the concept of what is the meaning of polynomial. What is the meaning when we say a polynomial can be factorized? What is the meaning of factors of a polynomial? That is why they are struggling to solve this question. Okay, moving forward. Yes, Saloni, you want to take this up?
Diksha. So, a class 10 polynomial question which states that given below are two facts about a polynomial p of x. Statement 1 says that x minus alpha is a factor of p of x, and statement 2 states that x minus beta is not a factor of p of x. Which row provides the direct inference and that can be drawn from statement 1 and statement 2? So yes, statement 1 and inference from statement 2 are the options. Yes, Diksha, if you can help us with the data here.
Yes. Yes. This is an application of factor theorem. I intentionally picked this up because in the previous slide we saw that students were struggling to identify the meaning of factors and the process of factorization, and how will that affect the when they study advanced theorems and results like factor theorem. Let us first try to dissect this question and see what the correct answer is. So the question says two facts about the polynomial is known. What is the first fact? X minus alpha is a factor of p of x. What is the second fact? X minus beta is not a factor of p of x. Okay, if they have understood the factor theorem well, then what do they infer from these two? Either, let us consider statement 1. X minus alpha is a factor of p of x means either p of alpha will be 0, or when p of x is divided by x minus alpha, there is no remainder. Right? Okay, coming to the statement 2, what one should infer from statement 2? Either x minus beta is not a factor of p of x. That means p of beta is not equal to 0, or in other words, when p of x is divided by x minus beta, there will be a non-zero remainder, right? Okay, now coming to the options, look at the first options. Dividing p of x by x minus alpha leaves a non-zero remainder is wrong. So let's move ahead. Dividing p of x by alpha leaves 0 as remainder is very tempting. But there is a mistake here, because p of x shouldn't be divided by alpha alone. It should be divided by x minus alpha, right? So let's discard option B as well. Look at option C. P of alpha is equal to 0. Correct. One of the interpretation of factor theorem says that P of alpha is 0. Let's look at its counterpart. It says P of beta is non-zero, which also matches with statement 2. Hence option C is correct answer. But what did actually students answer? They have gone for almost for 34% have gone for option B. Now what is the issue here? The issue is that students have understood the factor theorem well, but hey, there was a power cut. I have just connected via hotspot. Can you hear me, Saloni?
Yes, Diksha.
Yeah, I'll share my screen again. Sorry for the interruption. There's a power cut.
No problem.
Yeah. Favor B. Okay. Can you see my screen, Saloni?
Yes, yes.
Yes. So I was saying why students have gone for option B is because they are comparing whole number division with algebraic division. They see alpha as a whole number, they compare it with whole number division, and hence they are going towards option B, right? Again, it shows that students do not have in-depth understanding of polynomial division, meaning of fractions, and that is why they are making this kind of mistakes, right? All right,
Correct,
let's
Diksha.
go ahead. Huh.
Yeah, so Diksha, quickly, if we can just have a look at certain kind of remedies. We are coming to the end of our webinar.
Yes.
So before we move ahead,
Right.
yes.
Right. I would like to suggest this wonderful concept of algebraic tiles to teach polynomials, factors, and factorizations. I have picked this up from a website called Polypad. This is a wonderful website. You can use this not only to teach algebra, but there are several options, like you can use it to teach geometry, number sense, operations of numbers, algebra, etc. The link, the source is also mentioned here. Maybe you can take a note of it. Let us try to see how to use algebraic tiles and teach factorization among the students. This might require some reading to be done at the end of teachers, because it is not straightforward. There are, if there are negative coefficients, you need to use the red side. If there are positive coefficients, you need to use the green side. These kind of conventions are there. So I would suggest you go through the material once, or maybe you can use GPT and just ask it how to use it. Now, look at this quadratic polynomial x square plus 3x plus 2. This I'm representing with x square. So the coefficient is 1. So 1x square, one tile. If the coefficient was 2, then I would have chosen 2 of this kind of squares. Then we have 3x plus 2. And among these two, we should always first consider the scalar or the constant. So 1 and 1. Because we have 2, I have chosen 2 single ones. And once you arrange x square and 1 like this, you have to arrange the remaining x's. So 1x, 2x and third x, such that you get a complete square. Once you do this kind of arrangement, how will you find the factors? You need to measure the length on the horizontal top surface and the vertical left side. Now, how do we measure this length? The first length is x, because you remember this one we used as x. So the length of this is x. So this becomes x. And the length of this is 1, because 1 is represented by a 1 by 1 square like this. And this length is also 1. Similarly, the length of this on the left side is x, again from the same logic, and length of this is 1. Now add this x plus 1, x plus 2 is one factor, and x plus 1, x plus 1 is another factor. If you multiply x plus 1 and x plus 2, you will get x square plus 3x plus 2. So students will enjoy this kind of tools if you let them play with this kind of tools. I wouldn't say use this to teach the concept of factorization, but once you already teach them the concept of factorization, you can ask them to play with this kind of tools. And we all have a heterogeneous classroom, right? There are all kind of learners. We have audio learners, we have visual learners, we have kinesthetic learners, and this kind of tools will help both visual and kinesthetic learners. Over to you, Saloni.
Yes, Diksha. Very interesting way of learning algebra, in fact, which is a very abstract concept in itself. Anyway, so yeah, a great tool. However, we also have certain free things available on our website as well. So apart from what Diksha suggested, Diksha, if you can move the slide, please. Yeah, so we have freely available resources available on our websites. We have certain MCQ guidelines that are multiple choice questions. We have something called the AQAD, which most of us are aware about. That is asset question a day. Every single day, you get an asset question on this. You can register yourself freely out here, and you can be using this kind of questions every day for each and every subject. And after 24 hours, you get an answer towards it. You can use these questions to introduce new concepts into the classrooms or as a part of your worksheets or anything as such. Also, apart from that, we have only around 10,000 of questions on EI Diksha portal as well. So those are the competency-based question sets, which you can find out for various subjects out here. Apart from that, Diksha, if you can move the slide ahead, please. Diksha is stuck. Diksha, can you please move the slide ahead, please?
I think there's a lack. I have moved.
We are any which was at the end of our slide. This were the actual freely available resources which I would like all of you to look into. Also, we have certain misconceptions series coming our way. That is for science, which is the very next on the
Yeah,
17th of
I
September. That is
moved
tomorrow.
actually. That's the lack. I share.
Fez,
So
if you
can
can
you
just share the feedback link as well, please, because here we are not able to move ahead with the slide. So, teachers, your feedback is very important for us to improve. Every now and then we have the webinars so that we can improve with each and every webinar if you give us a good amount of feedback. So, requesting all of you to fill up the feedback form here. Fez, if you can please share that. Yes, so we have a link here to the feedback form. So I request all of you to please fill that up. We'll take 2 minutes here to just help everyone fill up the feedback form. We also have it on the screen. If you can scan the QR code here as well.
We also have more this kind of webinars coming up. Yesterday and today was math, and we have science, social science, and English webinars coming up in the same week. So I would
Yes, the
request
chat.
all the teachers. Huh, okay. Yeah, I would request all the teachers to inform this to your counterparts, science, math, sorry, science, social science, and English teachers, so that they can also benefit from this webinar series. Yeah, and
All
also
right,
please,
teachers can. Yeah.
Yeah,
Yes,
kindly fill. Yeah, I hope they're filling the feedback form,
yes,
right?
yes, they are filled up almost. They are two
Yeah,
minutes done. So thank you, teachers, for being patient enough. And here is the link for our upcoming webinar, so you can freely register yourselves as well. And since, as I said, that the next webinar on the 17th, that's tomorrow, it's on science. You can ask the science teachers of your group as well to be a part of it, and as well as you can join in. So thank you so much, teachers. Thank you, Diksha. Thank you, Fez. And we'll see you next time. Have a
yeah.
great evening. Have a good day.